Good morning. Today we are working on our next objective in this unit. Oops, that's the wrong one. We have today and we have tomorrow. So this is a short unit for us, just this week's objectives, only 4 objectives on this test. Remember, there is no review day. You are responsible for making your own help sheet for these 4 objectives. We have today's objective, we have tomorrow's objective, Friday is field trip, so no retakes. Monday is Memorial Day, so no school. Practice test Tuesday, real test Wednesday. Okay. So make sure you're ready with that help sheet by Tuesday. Let's look at today. CO74. I can calculate the probability of compound events. So we worked with probability on the last objective. Remember, desired outcomes over total outcomes. Now we're going to see what happens when we have several events happening. So a compound event is when there are 2 or more events occurring. And remember what we talked about with those events. An event is when we are taking an action for something. You're picking a card, you're picking a marble, you're flipping a coin, rolling a dice. Every single time you do an action, that is an event. So to find the probability of a compound event, you find the probability of each event, then multiply the probabilities together. So these are the fractions, not the percentages. So those initial fractions that we find. So you find that fraction for each event, and then we multiply all those fractions together. So let's look at what that means. We're going to take what we did yesterday, and we're going to look at what events we all have happening. Yesterday we had 1 event happening. What's the probability of picking a red marble out of the bag? Okay, so we're going to look at that, and then we're going to see how many events we have happening, and we're going to do that probability fraction for each event. Then we multiply it. So we have a bag of 20 marbles. What does that tell us? Rhoda? Our total possible outcomes are 20, right? So that's going to be the denominator. There's 20 marbles in the bag. We know our denominator now. 5 are blue, 8 are red, 7 are white. So what is the probability of choosing a blue marble, replacing it? Remember, we have to pay attention if we're replacing or not replacing, because that changes our total outcome for the denominator. And then choosing the red marble. So we have how many events happening? Joy. What are my events that are happening? So remember, the event is the choosing. So the replacing the marbles, it's an action, but it's not an event. You're just putting it back in the bag. So it's 2 events, okay? We choose a blue, and then we choose the red. So we have 2 events. So event 1 and event 2. What is my probability for event 1? We already know the denominator. Who can tell me what that denominator is gonna be? Alex? 20, because there are 20 total possible outcomes. Remember, for probability, we have desired outcomes over total outcomes. So if we want to choose a blue marble, how many desired outcomes are there if we want to choose a blue? Michael? 5. There's 5 blue marbles. Now we have event 2. We replaced the marbles, so we still have 20 marbles in the bag. Same number of total outcomes. What is my desired number of outcomes? Jack?
8.
8, because we want to choose a red marble. There are 8 red. So I have my 2 events, those 2 probabilities. What do I do next? Look back at our finding the probability of the compound event. Compound means there's more than 2 or more happening. What do I have to do with those 2 fractions, Alex?
Multiply them together.
Multiply them together. How do I multiply fractions? Andrea? I multiply straight across. So what is 5 times 8? Matt?
20.
What is 20 times 20? Matt? 400. Now, we finish it off like we did when it was just a single probability. Now we look at that and we say, okay, 40 divided by 400 is what decimal? Matt?
0.1.
So, what percent is that? Jackson?
10%.
10%. Okay, so we're doing what we did in the previous objective, but we're doing it however many events we have. Then we're multiplying the fractions, finishing it off with our percentage. Michael?
Are we also doing likely or not likely?
It does not say in the directions to do likely or not likely. You can think it in your head, but you don't have to write it. Let's do our next one. Choosing a red marble, not replacing it, then choosing a white marble. How many events do I have happening? Jackson, tell me what events there are.
The red marble, the white marble,
And that's it. Remember that replacing or not replacing isn't an event. It's just we need to pay attention because what is the not replacing it going to do for our probabilities? What does it change when we don't replace it? What is it going to change, Vinny?
the amount of marbles.
Yeah, it's going to change our total outcomes, how many denominator outcomes we have. So if we don't replace it, that number will be different. So let's look at our first event. Choosing a red marble. What is that fraction? Michael? There are 8 red marbles out of 20 marbles. We don't replace it. What is the fraction for the white marbles? Leo?
7.
Out of? So remember, not replacing it. What I like to do when I'm on this objective and I look at the word problems, I circle, am I replacing it or not replacing it? And when I see not, Leo, I know that number is not going to be the same for our total amount because I chose a red marble and I didn't put it back in the bag. So how many marbles are left in my bag if I don't put the red one back in it? I had 20. I had 20 and I take 1 out. 19, so it's gonna go down by 1, because that one red marble that I kept out, I don't put back in, so it's going down by 1 number. What do I do next? What do you think I'm gonna do next, Mallory? Multiply. Remember, when I multiply my fractions, multiply straight across. So what is the probability of choosing a red, not replacing it, and then choosing a white? What is my fraction going to be? Vinny?
56 over 380.
So 8 times 7 is 56, 20 times 19 is 380. Now what do I have to do? Rhoda?
Divide it.
Divide it. What is 56 divided by 380? Michael?
0.15.
0.15, which is what percent, Michael?
15%.
That is my final answer. All right, I'm going to erase so I can scroll up. All right, next one. Choosing a blue marble, replacing it, then choosing a white marble. Write down your event 1 and event 2 fractions, because we had choosing a blue, choosing a white, paying attention that we are replacing it. Write down your 2 fractions. And then you can do all the math. We're gonna work on it first and then talk about it. So we choose a blue, replace, choose a white. You are gonna want your calculators out. I see some of us trying to do this without calculators. Whew, this is big math. We want our calculators, friends. We should all have it out, work it through, and then raise your hand when you get an answer. So figure out your probabilities, do all of the math, raise your hand with the final answer. You gotta let me know when you get that final answer. When we get about 2/3 of the class getting this one done, we're gonna start talking about it. Okay, Moses, what is the first fraction we had?
I don't think I got it right, because I got 8.8.
Nope, listen to what I asked you, not final answer. What is the first fraction you put down?
Oh, 35.
Okay, that was the multiplying it. Step back to here. 5 over 20. So our first event, blue marble, was 5 over 20. What was the second one you had, Moses? We know there are 5 blue and 7 white. We know we had 20 marbles. We replaced it, so we still have 20 marbles. So then Moses looked at that and he said 5 times 7 is 35. What did you get for the denominator? Yeah, 400. So that is absolutely right, Moses. Then what did you do? Or did you divide 35 by 400? And what did you get? 0 point what?
0.
Okay. So that is our decimal. Now, when we have a big long decimal, when we turn it into a percent, what place do we need to round it to? Presley? The hundredths place. So remember, when we round, we look at the number after it. If it's 5 or more, we round up. If it's 4 or less, let it rest. Keep it the same. That 8 is followed by a 7. So what do I need to do with that 8, Moses? Yeah. So that turns it into a 0.09. What percent is that? Jackson? 9%. So you did it all correct. We just had to round to that hundredth place. Thumbs up, thumbs down. How many of us got 9% as our final answer? If you didn't, that's okay. That's why we're working on it. Okay. Do the next one. Choosing 2 blue marbles, not replacing either, then choosing a red. I'm gonna tell you, really think through how many events are happening. So take a look at it. Show me with your fingers if you think you know how many events are happening. Show me with your fingers how many events there are. How did you get 3, Presley? So choosing a blue, and then choosing another blue, then choosing a red. So that is 3 events. Choosing a blue marble, not replacing it. Think about how that's going to change your numbers. Choosing another blue, not replacing it. Again, thinking about how that changes your numbers. And then choosing a red. So do all 3 events, multiply it, divide it, turn it, your decimal into a percentage. When you've done all that, raise your hand for final answers. Oh, wait. Sorry. So choosing a blue. How many times are we choosing a blue marble? How many times did you choose the blue? So, Bailey, look. How many events do I need to see? Yeah, you only did 2 events. Not replacing either. Are we gonna look the same if we don't get that blue marble back in the bank? Think of how it changes your numbers. Into the blue marble. Don't replace it. If we do a blue marble out and we jump to the second tab, how many are left? Same thing. If you make a blue marble out and we don't put it back in, how many are left in the bag? Do we have 5 in there? We have 5 in there, we take one out. How many are left in the bag to choose from again? So why is there only one design? How many marbles to choose from? Better means those 5 as well. blue marble out. I have 5, I take one out, and don't put it back in. My second pick, how many do I have to choose from? Simple. How many are in the bag altogether? Yeah. And then 19, and then 18, and then... Oh, there are a lot of us that are almost there. 2 blue marbles. There are 5 blue marbles out of 20. I take a blue marble out, and I don't put it back in. How many blue marbles are left in my bag? If I had 5, I take one out, how many are left in the bag, Moses? 4. And that blue marble that I took out makes it go from 20 down to 19. I don't replace it, so my next one is only gonna have 18 in it, but this time I wanna choose a red marble. So yeah, it gets a little tricky. We have to really think about what our actions are doing to what's left in the bag. So we had 5 blue, we picked one, now we only have 4 blue left and there's only 19 marbles left. Then we pick a red out of 18. We multiply them all across. 5 times 4 times 8 is 160. 20 times 19 times 18 is 6,840. We're going to divide, and we get 0.02, or 2%. There's a reason why we're doing this page together, so we can catch those tricky ones, okay? You really have to pay attention to all those little details. Now, the next one says, which is more likely? Choosing a red, not replacing, choosing 4 red. So how many events is that? 4 events. We're choosing 4 red, so that's 4 events. We're not replacing them. So that's gonna change our total outcomes because we're not replacing each other. It's also going to change how many reds are in the bag. Or choosing one of each color, not replacing either of them. How many colors do we have? We have blue, red, and white. So that is 3 events. So that means we have to do 2 separate problems. Our first one is choosing 4 reds. So we have 8 reds out of 20. I don't replace it. So now I have 7 reds out of 19. Don't replace it, so I have 6 reds out of 18. Don't replace it, I have 5 reds out of 17. I multiply across, and I get 1,680 over 116,280. Figure out what that percentage is. Over here, I have 5 blue out of 20. I don't replace it, so now I have 19. Don't replace it, so now I have 18. I want to choose a red, and I want to choose a white. Multiply those across, divide, and get that percentage. So finish that problem off. Raise your hand when you know which one is more likely to happen. So did you do both sets of problems, Julie? We're on this one. And nowhere on there do I have 1 out of 20. Look up at how I walked us through the 4 reds. probably with one less ready each time. Be careful with your rounding your decimals. Careful where to be round with those decimals. I don't see any work. Oh, sir, we show our work. All our work. I've got a ton written up there. You should at least have all that written. What's the work that you're doing? Good. Is this the second one? The second one is close. So this is 0.01, what percent is that? I'm not sure what percent it is, it's 5%. So this was 4%. This is 1%. Which one is more likely to fit? You were almost there. Good. Good. Yes. Yes. All right, let's look at this. When we divide 1,680 by 116,201, what is the decimal that we get? Who can tell me what the full decimal is without rounding it? Michael.
I believe it.
Who can tell me the full decimal without, before you rounded it?
Okay.
Michael?
0.01444788.
Okay. So, we're gonna stop. Once we get past the thousandths place, we don't need it. Think about what we talked about. We round to that 100th place. I had multiple people look at this and say 14%. That's not stopping at the 100th place. You can only go 2 spots over, and then we have to round it. So we have a 1, that's followed by a 4. If it's 4 or less, let it rest, so that 1 stays the same. It is only 1%. There's a big difference between 1% and 14%. Now, when we have 5 times 8 times 7, we should have gotten 280 over 6840. When I divide that, what is the decimal I get for that one? Going to the thousandths place. Who can tell me that decimal? Presley.
0.040.
Okay, so I look at that hundredth place, it's followed by a 0, 4 or less, let it rest. So that is 4%. So not only do we have to pay attention to what those fractions are, we really have to think about rounding our decimals. Okay, think about where the hundredth place is, the second decimal spot. That is the last number we can have. We have to be very careful. There were too many of us that were putting 14% instead of 1%. We have to pay attention to where that hundredth spot is. One last one to do together. You choose 2 marbles from the bag. How many events is that? 2 events. We're going to replace the first one. What is the least likely outcome? Oh, do we actually have to do the math, or can we use logic in our brain? Mel, you're using logic. What did you think?
I thought it was one when you picked first a blue, and then the second one was a white.
So why did you pick blue first?
Because that one was 5.
Yeah. What do you think our second one would be? Another blue. So choosing 2 blues because there are the least amount of blues in the bag. So the least likely combination we get is choosing the 2 smallest numbers. So each one we think of what the smallest numbers are. Most of them are not going to be a logic. You have to show your work and do all the math. So our second page is our work page. You have a spinner with 4 equal sections, red, blue, green, blue, and yellow, and you have a dice that has 6 sides. Okay? We need to, first thing you do is figure out what events you have happening. So we have spinning a red, and then rolling a 5. Are there the same amount of outcomes in the spinning and the rolling? No, there are 4 outcomes for the spinner. So that would be over 4. And there are 6 outcomes for our dice. So there's 4 total with the spinner, 6 total with their dice. Think about how many desired. Remember, you multiply, then you divide down, and use that decimal to turn it into a percent. Some of these have multiple things we're doing, spinning, rolling, spinning. Okay, think about each event. What is that fraction, probability fraction for each event? Multiply it all across, divide it down. Give me a percent. Any questions? Okay. If you are watching this at home, I hope you are well, and I hope to see you soon. Remember, go slow. Make sure you're doing your events carefully, and make sure that you're catching those little details. Okay, this will be tested on next week, so really get the practice with it. Have a wonderful day.